The Unix system provides several system-related calls which create and end programs, which sends and receives software interrupts, which allocates memory, and which helps in doing other useful jobs for a process. Four system calls are provided for creating a process, ending a process, and waiting for a process to complete. These system calls are fork and the exec family, wait and exit system call. The fork system call. System call fork is used to create a process. It takes no arguments and returns a process ID. Suppose a fork is to create a new process. The purpose of fork is to create a new process, which becomes the child process of the caller. After a new child process is created, both processes will execute the next instruction that follows the fork system call. Therefore, we have to distinguish the parent from the child. This can be done by testing the returned value of the fork system call. If the fork returns a negative value, the creation of the child process was unsuccessful. Or in other words, child is not created at all. If fork returns a 0 to the newly created child process, and the fork returns a positive value, which is the parent process, the process ID of the child process. So the parent process gets the process ID of the child process. The return process ID is, however, of type PID underscore T, which is a type def structure defined in sys slash types.h header file. Normally though, the process ID is an integer. Moreover, a process can use the function getPID to retrieve the process ID assigned to this process. Therefore, after a system call to fork, a simple test can tell which process is the child. It is important to note that Unix will make an exact copy of the parent's address space and gives the copy to the child. Therefore, the parent and child processes have separate address spaces. Let's take an example to make the previously said points clear. This example does not distinguish the parent and child process to fork. This is a simple program where a fork has been called by the main process that executes it, creates the process as a child, and then both the child and the parent processor starts executing the for loop. So when we run this program, we can see that the line printed will print for twice the maximum count, and that will be for both the processes. As you can see, now one of the process is executing the process ID 6051, 6015, now 6014, again 6015, again 6014. You can very well figure out that the synchronization between both these processes is not there, because the program does not synchronize the parent and child processes. This synchronization is done by the operating system itself. If we stop the process in between and examine the printed output, then you can see this process with process ID 6051, which is the child process, has executed the statement inside the for loop 3 times before getting stopped. Before that, the parent process has executed the statement 4 times, and then before that the child 4. However, this synchronized way will not be there if you go and move into it. As it is in this case, this is the child and this is the parent. Clearly the child has executed more times than that of the parent. FG will rerun the process. We can explain briefly about the following program in the next section.